Yeah, Fadil is there. Right, but today
So
we will
Ian
move
will
up
also
to
come.
here will come, right? Well, yes. But, yeah, we'll go ahead with this. Yeah. Today our topic is to learn about the reducible first order differential equations. Right. Okay. So over here we are starting with yeah. Today our topic is to learn about the reducible differential equations with the differential equations, right? Okay. So when you come up with this kind of situations, so what you need to do is they have to give us a show that the substitution y equals to xz for the dy by dx is equals to this one can be reduced into this format. That is the section where we need to understand in this question. One second, Pate. Okay, then we will start up of doing this question. Yeah, the first question over here is it's just like this. They have given us this format of it. dy by dx is equals to x squared plus 2y squared divided by 2xy. They ask us to use a substitution y equals to x z, right? Then they ask us to finally turn up into dz by dx format. So the reduction format is dz by dx. So this is what you have done. dz by dx. That means this is an equation of z in form of x. That is, then only you can get this dz by dx. That's a fact we have to understand. That means in this final what we call as replacement, we have to remove this y. That means the equation is in form of z and x. That's a fact we have to understand by giving this format of it with it, dz by dx. Right. Again, what you need to do is replace this y. You have to remove this y out of this equation. Then from here you can say y equals to x z. Then we need to find some expression for dy by dx from this equation. That's a step of doing it. From this equation y equals to x z, we need to do it. Right. dy by dx. So we have to differentiate in terms of x. Keep x and differentiate z. Product rule we are using dz by dx. Then keep z. Then replace with x. A differentiation of x is how much? The differentiation of x is 1. So therefore you can write dy by dx equals to x times of dz by dx plus z. That is the answer for that. Then what you can do here is that then we can replace with this. So instead of this dy by dx, we replace with this. That may equation again. From here, what you can do here is you can say this one million. Just you can write x dz by dx plus z is equal. So now we have to replace this x squared and y squared, these terms over here. Replace so that is so you can say yeah, this way. You can write x squared plus 2y squared plus 2y squared with it. Y squared you can put xz whole thing squared, because you need the final answer in terms of this much 2xy 2x is 2xy y not you can replace x is right. Then let's try to simplify this. So you can say x dz by dx plus z is equal to make a simplify x squared plus 2x squared z squared divided by like this 2x z 2x squared z, right? Then in this expression what you need to find is this bit. Then අපිට පෙන්නන්න කියලා කියන්නේ x is x z. So we have to simplify in terms of this. Let's see whether we can just do some simplification of this x dz over dx. X dz over dx. So what I do is I just bring this z to other side. Then what happened here? X dz by dx is equals to x squared plus 2x squared z squared over 2x squared z minus z. Then from here, then what you can get here is that you can just make some so make simplify x dz by dx is equals to make simplify if you take the LCM, x squared so you can write x squared plus 2x squared z squared minus 2x squared z squared divided by 2x squared z squared. So with that you can understand that these two terms get cancels, turn up to x dz by dx is equals to x squared over 2x squared z squared. Right, I think that's the answer with the need. Yes, my 1 plus we just have you made any mistake over here? X squared cancel 1 over z squared එකක් ඇවිල්ලා තියෙන්නේ බලමු මොකද වෙලා තියෙන්නේ කියලා පුතේ. This is 3y squared. I think I made a mistake over here. මෙන්න මෙතන වැරදිලා තියෙන්නේ පුතේ. This is 2 නෙමෙයි, this is 3y squared පුතේ. එන්න මෙතන වැරද්ද වෙලා තියෙන්නේ. Here the problem is පුතේ. This should be 3 පුතේ. එතන 3 කළොත් මෙන්න මෙතන 3 වෙන්න ඕනේ පුතේ. මෙතන 3 වෙනවා. එතකොට පුතේ මෙතන මේකත් මෙතන 3 වෙනවා. මෙතන 3 වුණොත් පුතේ කැන්සල් වෙන්නේ සම්පූර්ණයෙන්ම. ඉතුරු වෙනවා මොකද්ද පුතේ? මෙතනින් මේක සබ්ස්ට්‍රැක්ට් කළොත් ඉතුරු වෙනවා මොකද්ද? x squared plus මෙතන ඉතුරු වෙනවා x squared z squared එක උඩ ඉතුරු වෙනවා. එතකොට මෙතනින් හැදෙනවා x squared plus x squared z squared. Then out of this fact where we can say that you can write x dz by dx is equals to, you can take x squared out 1 plus z squared over 2x squared 2x then you get a term over here. This is turned up to 2z squared, right? 2z squared x squared. The x squared and x squared get cancels. Turn up to x dz by dx is equals to 1 plus z squared over 2z squared. I think that's a fact. There we need to get it. Yeah, right, okay. Then hence find the general solutions of the equation y squared in terms of x. That means now we need to simplify this, right? Okay. Then x is at dx. So that is a fact where it's available with us. So yeah, then what you need to do is put here, this is a turn up to pretty simple equation. Then I'll just bring this, then I need to solve this differential equation. Right, then I'll just get this way. මෙතන තියෙන equation part B එකෙන් I'll start from here. X dz by dx is equals to 1 plus z squared over 2z squared. Then making, I'll just bring this x terms to one side and dz term to other side. Then I'll brought this because anyway dz and dx should be the numerator. So this is turned up to 2z squared divided by 1 plus z squared dz is equals to 1 over x dx. Then we can integrate the both sides. Then if you do this, how can you do this integration? When the main integration is converted, there's an issue where we come across is here. That means what you call that differentiation of the denominator is not available in the numerator. 2z squared means problem. 2z squared 2z z that's correct. Z squared z squared this is not there. So this is just like this. So straightforward, you can see the differentiation of this is available in the numerator. Differentiation of 1 plus z squared is here. So make ln 1 plus z squared is equals to ln x plus c, right? Okay. So that is the answer for that, right? Okay. Then what we need the answer in terms of x and y, not in z and that stuff. So make it a simplification karana me c ganna yeah, with just when you're writing this c without writing c, I'll just write like this memory make you can see all other integration terms are in ln. Therefore make a this one also I write in form of this way. Make a this one also I write with ln c. Make a ln 1 plus z squared is equals to ln xc. Ln and ln you can cancel and you can write it 1 plus z squared is equals to xc. Right? We cannot find c here because there is no other boundary conditions are there. Then what what we need the answer in terms of x and y. Therefore replace this x. The substitution we are using is x. Y equals to x is that. Then what you can get here is make x is y when what I would have write x is z, x is z. So z so you the substitution here is y equals to x is z, but in a final answer you need terms of x and y. Therefore you can say z equals to y over x. Then make a replace 1 plus y over x all things squared is equals to x. Then make a simplify 1 plus y squared over x squared is equals to xc. Then you can say y squared over x squared is equals to xc minus 1. Therefore, y squared is equals to x squared times of xc minus 1. This is the final answer for that. That's a way of getting this answer. Right. Okay. Is that clear? It's a little bit of long and kind of yeah, confusing, but you have to practice this kind of situation. So if you just basic workout for this question is make up they have given dy by dx, this is the expression. They have given this substitution. Your final answer you need in terms of dz over dx, but that means y is not there. So what you need to do is equation again, you have to remove y from this equation. That is the what you call fact where we need to understand in this question. But make a y I in color, then do the usual differentiation in terms of that. Right. Okay. That's fact we have to get it right. Question. Yeah. This question, what they have given here is this is again, if you work out over here, yeah. Yes. The question they have given here is dy by dx is equals to x. Dy by dx, sorry, this is not just So according to this equation, given fact is dy by dx plus xy is equals to xy squared to them. Then they have given a substitution y equals to, sorry, z is equals to y to the power minus 1, right? Then we need the final answer into a differential equation y and x. That means you have to remove y. So this one you can say z is equals to 1 over y. Therefore, you can say y equals to 1 over z. Right. Then we need to remove y out of this equation. So making up a gandapul one, that means you need the equation in terms of x and z. Therefore, we need the yes. Here you have expression for dy by dx. Therefore, you can write over here. Dy by dx, you need some substitution. So here this is not in terms of x pute. So 1 over is a differentiation is how much, that is so this is correct, this is s to the power minus 1. So this is minus 1 is a to the power minus 1 is minus 2 into, since this is not a differentiation format of x, you can say dz over dx. So මෙතන answer එක තමයි minus 1 over z squared dz over dx. That's a requirement where we need to do, right? Okay. Then over here, now I'm going to replace with this. dy by dx I replace with minus 1 over z squared dz over dx plus xy. Y you can replace with 1 over z, that is x over z, is equals to x over z squared. So you have to just do like this. Then you can understand that just multiply multiply with everything with minus z squared. This is the answer, but anyway you can do a little bit of a simplification over here. If you multiply everything with say minus z squared, you get the answer here dz by dx minus xz, minus z squared multiply cancel of it equals to minus x, right? Then what you need to do is we have to do this differentiation. Now you can see here this is xz and minus x over here. Yes. Then after problem here the number here is 1. The differentiation of that is not there. But here the differentiation of this is over here. It's not a problem with that. So therefore you have to use the integrating factor format to get the part. Sorry. Yeah, that's it. So this is the part 1 answer. So here this is a part 1 answer. Then we need come up with part B. Part B, what they expect you to find in part B, solve the new equation using the integrating factor. Then part C is find the general solution of the equation in terms of x and y. Right? Okay. Then බලමු මේ කොහොමද කරන්න කියලා පුතේ. දැන් මෙතන බලන්න මේක part B එක කරනකොට here the differentiation is not available here, but here the differentiation is there. So just you have to use the integrating factor for this පුතේ. IF එක ගන්නවා. IF එක කොහොමද ගන්න පුතේ? Yeah. If you get the integrating factor, IF e to the power integration of, if you remove this, it's minus x. Right. So this answer is e to the power minus x integration is minus x squared over 2. Right. Then I can multiply everything with what? E to the power minus x squared over 2. So what do you get with it? Then this equation turn up into this part of it. Minus, sorry, e to the power minus x squared over 2 dz by dx minus x times of minus x squared over 2 z is equals to minus, sorry, e to the power minus x squared over 2 into minus x. Right. Okay, then here the differentiation is available here and here the differentiation is available here. So you can simply write this fact is differentiation of e to the power minus x squared over 2 into z is equals to minus x e to the power minus x squared over 2. Right? Okay. Then we will integrate the both sides. If you integrate the both sides, what you get here is straightforward. This side, not a problem. It will turn up to e to the power minus x squared over 2z is equal to, here you can say the differentiation of this is available here. So you can straightforward write this is e to the power minus x squared over 2 plus is the final answer for that. There with that you can write, but you need the answer in terms of x and y, not with z. Then I can replace over here, z is equal to 1 over y. Z is equal to 1 over y. So this is turned up to e to the power minus x squared over 2 over y is equals to e to the power minus x squared over 2 plus c. So with that, you can write y is equals to e to the power minus x squared over 2 divided by e to the power minus x squared over 2 plus c. That's the answer for that. That's a way of getting this answer. Right. Okay. Over here, they have already done with this question. Right. When you come across with this question today, Maker, I hope you have your textbooks with you. Right. Over here, they ask us to use a substitution of dy by dx equals to y minus x plus 2, y minus x plus 2 over y minus x plus 3 to convert into the equation of u and x. U and x. It's a conversion of u and x. That's a fact where they are talking about, right? Okay. Then initially, let's go ahead with this. Question here initially make with question dy by dx is equals to y minus x plus 2 over y minus x plus 3. You need the equation in terms of u and x. U and x. We need the equation in terms of this. Then how are we supposed to do this question? They have given the substitution u is equals to y minus x. So initially, I'll find some expression for, so from here you can write y equals to u plus x, right? Then I can find what is dy by dx. If you differentiate dy by dx, see the variable is 1. So this is turned up to du by dx plus differentiation of x is 1. That's a, we have to keep this answer separately. Then I replace this part of it. From here, what you can write, instead of dy by dx, you can write du by dx plus 1 is equals to y. What you need to do is at subject y. Y is u my u plus x. U plus x minus x plus 2 divided by u plus x minus x plus 3. So this is turned up to u minus x, then turn up to u plus 2. U plus 2 over u plus 3, right? Okay. Then what you can get here is du by dx is equals to u plus 2 over u plus 3 minus 1. So this is turned up to du by dx is equals to u plus 2 minus u minus 3 divided by u plus 3. That is turned up to this 2 get cancels over here. Turn up to minus 1 over u plus 3. That's the answer for that. Then you can write du by dx is equals to minus 1 over u plus 3. That is the answer for part A. Then part B, they ask her to solve this part of it, solve this equation, part B. So what you can get here is that you can take u terms to one side. U plus 3 du, sorry, u plus 3 du is equals to minus 1 dx. Then we'll integrate the both sides. Then what you get with it? Then you get u squared over 2 plus 3u is equals to minus x plus c. Then they need the answer in terms of they need the final answer in terms of y and x. That's a part C answer. This is the answer for your this is a final differential equation. We have to find value for C if they are given the boundary conditions, but it's not given such thing. But you need the final answer in terms of x and y. Therefore, from here you can write u equals to y minus x. So I'll replace over here u equals to y minus x. So you can say y minus x squared over 2 plus 3 times of y minus x is equals to minus x plus c. So if you simplify this, you can get the answer for y in terms of x. So this is the final answer for this. Right. That's a way of doing this kind of a question. Right. Example like yes. If you come across this question, පුතේ මේක දැන් ඔයගොල්ලෝ work out කරන්න ඕනි at home other than what you need to do is after that you have to ask this question and to verify with the things where you have to do, right? Because we cannot do all the question in the class, right? So it's a part of it's not part the main part major uh, section is with you in your hand, right? Okay, so here if you go to exercise 5c 5c part A, question number 1. Part A, the question is Pate, dy by dx is equals to y over x plus x over y. Right. The substitution they have given here is z equals to y over x. Pate. Z is equals to y over x. They need the answer in terms of x, z and x. Pate. Z and x. Right. Therefore, from here you can write y equals to, sorry, from here you can write y equals to x z. Therefore, you can write dy by dx is equals to keep x and differentiate dz by dx, and keep z and differentiation of x, it's 1. So we can replace it over here, x dz over dx plus z is equals to y. Y we know you can replace x z with it. X z over x plus here x over y we know දාන්න පුළුවන් x z කියලා. එතන මෙතන simplify කළොත් එනවා x dz by dx is equals to මෙතන cancel වෙනවා අපිට z එකක් plus මෙතන 1 over z එකක් හැදෙනවා and minus z comes over here, right? Okay, so with that what you can get here is you can cancel this z with z, so you can say x dz over dx is equals to 1 over z, right? Okay, so you can then this is a part A answer. Then you have to solve this. How to solve this factor of it? So you can take this z terms to one side. Z dz is equals to, if you brought this x to other side, 1 over x dx. Then you can integrate the both sides. Then what is that answer over here? Z squared over 2 is equals to ln x plus c. So you can write z squared equals to 2 ln x plus c. C multiplied by 2, even you get the same factor of it. So after that, they might ask you the question in terms of x and y. X and y, that means z has to be replaced with y and x. Z is equals to, we got the substitution, x is equals to, sorry, x is equals to, sorry, y equals to is xz. So the measuring up factor z is equals to y over x. Z equals to y over x. Yeah. Z is equals to y over x. So you can replace over here. Y is y over x squared. Y, this is one whole thing squared. This is 2 ln x plus c. So with that you can say y squared equals to x squared times of 2 ln x plus c. On means 2 you can write the answer with that. If they ask you to subject y, you can say this is y equals to, sorry, y squared is equals to x squared. You can keep this ln x squared plus c. Then you can get the y equals to the square root of this bit with it. X squared ln x squared plus c. So just 1 second with it. Over here, you can say it's right. Then put the make a workout color. You get the answer square root of x squared ln x squared minus c. Then of you okay. So that's the final answer for that. Like that, you can do this kind of integrations. So that is what you need to learn under the substitution under the by making some kind of a substitution to get the answer for this kind of differentiation. Is that clear? Madhushani,
Yes,
Fadil,
sir. Yes, sir.
Fadil.
Okay, sir.
Yes. Then Yehen, you are there, right? Ay
Yes,
parakune. Why you get late, child? Nidagata. Na nidagata. You were there in the morning session.
yes.
Yeah.